Hello everyone. Today we will look at a small PPT or a video on fluid machinery. I am Dr. Ilangovan and I am a professor in the Department of Aerospace, SNS College of Technology. Let's get started. Now, what is a fluid machine? It's a device which converts the energy stored by fluid into a mechanical or in a mechanical energy or vice versa. The energy stored by the fluid mass appears in the form of potential energy, kinetic energy, or the intermolecular energy. The mechanical energy, on the other hand, is usually transmitted by a rotating shaft from one end to another end, where it is made a useful uh, output. Machines usually uses liquid, mainly water, for all practical purposes and are termed to be hydraulic machines. So there are incompressible fluids and the compressible fluids. The one which works on incompressible and is categorized here, and there are power consuming machines and power generating machines. If it is the power consuming machine, it is called as a pump, and in that you have the fans, blowers and compressors. They all consume powers. Whereas the other kind of machine or fluid is the power generating machine, where you have the hydro turbine, you have the steam turbine, which is rotated by steam, you have the wind turbine, which is rotated by wind, and you have the gas turbine. Now, turbo machines or fluid machinery is what we are going to look today. They are positive displacement machines, and we have one is a human heart, which is shown here, and the turbine or the water meter. The energy transfer to the fluid is accomplished by the movement of the boundary of the closed volume, causing the volume to expand or contract. Now, on the other hand, the dynamic machines, you have the rotating blades that supply or extract energy to the form of a liquid. Now, here there is an expansion of the chamber, whereas here there is no expansion of the chamber. Now, here you have the blades are rotating either to extract energy or to to move the liquid up. This is the centrifugal pump and this is a turbine. Now, what is the working principle of the pumps? Pumps are used to generally lift water from one level to a higher level to an overhead tank, and the water which is at the lower end below the ground is called as the sump, and you have a foot valve not to allow the water to go back, or the residues, etc., whatever is collected here, to be filtered out. Now, once the water enters through like this because of suction, okay, this is rotating. Now, when this rotates, an external power is is given, and then you have a vortex kind of a chamber here, and where the pressure increases, and then it pushes the liquid, sucks the liquid from here, and then it pushes the liquid to the higher level here on a overhead tank. Now, this point is called as the discharge level, and this is the water is there at this level here. Okay, and the center line of the pump is shown here. You have, these are the delivery pipe, and this is the suction pipe. Now, pumps are classified in many categories. So one is a positive displacement pump, in that you have reciprocating pump, which has a piston, a plunger, and a diaphragm. Or you have the a rotary pump, which have a vanes and the piston or a screw or a gear. Now, here we have from the pumps, we also have the, instead of positive displacement, we also have the dynamic pumps. The dynamic pumps are divided into or classified into the centrifugal pump as well as the special pump. Centrifugal pumps in turn are classified into the radial pumps, mixed flow pumps, and the axial flow pumps. Now, the special pumps, we have the ejectors, you have the electromagnetic pumps, as well as the gas lift pumps. Okay, so this is a gist of the total classification of pumps. Now, coming to the types of turbine, we have four different types of turbine. One is the water turbine, the steam turbine, gas turbine, and the wind turbine. And the turbine themselves are being, water turbine is classified into three types. One is the Pelton wheel, which is the most generally used, or then you have the Kaplan turbine, and then you have the Francis turbine. Three different kinds of turbines are there, and each one is have their own different ways of their usages. The Francis turbine and the Kaplan turbine are basically reaction turbine, where there is a jet of water hitting onto that, and then it uh, um, water comes out, and then because of that it rotates. Whereas in the impulse turbine, there is a jet which hits onto that and hits on the Pelton cup, and then in turn it moves. Now, pumps and turbines, here this is what there's a flow in, and then there's a pump here, and then a flow out. Energy comes in, pump is there, and then the energy flows out. Okay, here you supply the energy, and then you rotate it by here. E out is always greater than E in, or the energy out is always greater than energy in, because we are supplying energy here. A turbine extracts energy from a liquid here, flows inside, the turbine is there, and then it in turn rotates the shaft here. Okay, here the shaft is rotating the pump, whereas here it rotates the shaft. Okay, flow goes inside and flow goes out here. Energy extracted, E out is less than the E in. So because of some losses that really happens there. Okay, the head is given by the subtraction of the input and the output. Here you see the Bernoulli's equations have been used here. Here this part you see the centrifugal pumps. If you this is the pressure, inlet pressure, and then once it goes inside and gets, this is the output head. So the difference between these two is called as the head here. Now look at the summary. Uh, Today, what we have seen, we have checked what are pumps, what is a turbine, the difference between pump and a turbine. We have seen. We have also seen the classification of pumps. We have seen the classification of turbine and the principle of the working of pump and a turbine. Okay, so we will meet once again. So this is the end of our presentation and on machines, fluid machines, and thank you very much for being with me. Thank you.